Great. All right, so let's start. We will do some discussion about Heroku today, but to finish off what we were discussing yesterday, let me just quickly redo some things that we were doing. So one thing that one of the more advanced things that we were discussing yesterday was the concept of the map literal. So what is a map literal? Let's see. Yeah. Is the font big enough? So what's map and what's map literal? What's the difference? Yeah.
Map is the data type, and the literal is just how you create an Heroku without specifying all of the type. You can just create the map on the spot.
That's right. So for example, if I say I have A which is 10, right? What's A? A is a variable which holds a value 10, right? So if I do B equals A, B is now also a variable which holds 10, but I initialized it from a variable, not from the literal. 10 is a literal, right? So literal is something that is known at the compile time to have a value. So at the compile time, compiler knows this is value 10, right? It doesn't know what B is and so on because those things happen at the runtime, but literals are something that is known at the compile time, right? So if I have a map, so for example, if I have a map A and it's a map, oops, for example, string into ints, right? Then if I initialize it, if I say 1, 1, 2, 2, right? So now this expression here is a literal, and it defines a map at compile time. So the compiler will know, okay, here we have a map. And that's kind of a on-the-spot anonymous map that I've just created and initialized, right? A is highlighted because I'm not using it, so that's what the editor complains about. We were trying to define a constant map yesterday, and it turns out Go doesn't have constant maps. So Go only has constants for primitive types, for strings and for numbers, but not for complex types such as map. So we cannot do const A like this. We can do const B equals 10, right? So we can have a constant B with a value 10, but we cannot have a constant map. So that's what was the a small add-on for what we were discussing yesterday. So that's one thing. The second thing is we are struggling a little bit with the
So if you have make a map which is empty, is that a map literal? Or?
Yeah, it's an empty map literal. So
one example, what can give an example of a map which is not literal?
So if you say A is a map, so let's say I have a variable a, which is a map of some sort, right? So now a is not a literal, a is just a map. It's a pointer to a data structure, which is a map.
Okay.
So a, yeah, currently a is empty, right? Because it doesn't hold anything. I haven't added anything to this map. So a is empty, but a is not a literal. A is a variable pointing to a map, right? So if I said I have a, which is an empty map, now a is a variable, but this is a literal defining an empty map, right? So without those braces, this is not literal, this is just a type specification. With the empty braces, it basically creates on the spot an empty map. So you can say this represents a literal, right? You get it? So same with numbers, like, you can have, for example, 10. Interesting thing is with complex numbers. There was a discussion about complex numbers in the programming Discord. And my argument was that if the language supports complex numbers, you can have complex numbers literals, right? So I could, for example, say something like this, right? And then this would be treated as a literal of a complex number if the language supports literals like this. Otherwise, if the language doesn't support literals like this, then I have to say that a is of, let's say, time complex, and then I have to initialize it with functions, right? So I'm losing the simplicity of using literals for complex types. So some languages have a very powerful mechanisms for defining your own literals. In some languages, for example, you could say, you can say something like that a is 10 US dollars, right? And this expression is a literal defining a complex type, which means it's a currency with value 10 with the US dollars as a currency, right? In Go, we cannot do that. This is not a literal which we can use to define a currency, right? I can define a struct which represents a currency, and I have a currency type and currency value, but to initialize it, I have to use this dot notation or something like this, right? I cannot use a literal to initialize my struct. But in some languages, you have kind of a powerful mechanisms for working with literals, and then it kind of simplifies the way you initialize variables and things like this, right? Make sense? Okay, so that was it. What I was discussing, yeah. So the second thing is that we are struggling a little bit with those keys for the API for assignment 1. So I discussed last night with Christopher, and what we will do, we will probably rewrite it a little bit so you don't need to have a key to work with the API, because it turned out to be a kind of a painful process of actually getting a key. So somehow Christopher got the key, but I couldn't get the key, and many of you couldn't get the key, right? So we will change the spec a little bit for next week to not need to use the tokens for the API. So the structure of the assignment will be very similar. We will use the same API, but we will just modify it such that you don't need to use a token to access the data that you need to pull to create your solution. So hold on for a moment with with working on it until we update the assignment. So that's one thing. The second thing is we always have, because you are in a transition year, right? So in the first year, everything is organized, that you have deadlines and you have clear assignment deadlines, and you have to work for the deadlines that teachers give you, right? In the third year, a lot of projects are like at the end of the semester, you have to have something and you organize your own work, right? So you have a total freedom when you work, and most of you work in the last 2 weeks, right? Which is bad, because you should work kind of continuously. And in this year, we kind of in between. So some subjects kind of give you a very clear, well-defined targets, and some subjects don't. And we historically were kind of not doing that. So we were giving some deadlines, but they were just provisional. And what we basically need, we need all your assignments at the end of the semester to mark you, right? If you are working at the end of the semester, you will most likely be really struggling to finish everything. So you have to work kind of gradually to finish the assignments. But we don't care, like we are not here to manage time for you. Like you are here to learn to manage time for yourself, right? So there are two options. One option is that we will give you a deadline of what is the assignment 1 deadline, assignment 2 deadline, and so on. And you will have to submit those assignments by the deadlines. And if you don't, we kind of discard it. But that means we kind of managing time for you, right? The other one is we just tell you, okay, at the end of the semester, you have to submit all the deadlines, all the assignments and the project, and then you organize your workload yourself, right? For some students, the second model works much better. For some students, they don't have enough motivation to work and they postpone working on assignments until the very end, and then they really struggle, right? So I will leave it open. We will not make the decision today, but we will kind of, let's say, vote on it next week and then decide what we do, right? Whether there is a deadline for each assignment or whether we just wait for all your assignments at the end. I strongly advise you, if we go with the second model, to work on the assignments gradually and finish them as early as you can, because they kind of build on top of each other. So the assignment 2 will use some of the things from assignment 1, and the sooner you finish assignment 1 will help you to finish assignment 2. And also, we usually have a rule that you cannot get into a group project if you haven't finished assignments, because that means it's unfair for the group that you're still working on your assignments instead of working for the group for the project, right? So you will be not allowed to join a group project if you haven't finished the assignments, just out of fairness for working with the group. So even if we go with the second model, that will be the rule that will be in place, right? And then if you don't finish the project, you will fail the course, because project is kind of a big part of the course, of the internal assessment. So you have to have a project. So let's discuss it next week when Christopher is back, and then we will make the final decisions. All right, so if you have any ideas about this, or if you have any strong opinions one way or the other, let me know or let Christopher know, or post something on the course feedback wiki, right? So any opinions are welcome. I personally prefer the second model because I don't really care about your time management. When I was a student, I did a lot of work at the end, like just crashing, and it's okay. I mean, you can do that, but also I know for some students it's really bad. For some students, having the deadlines helps because they kind of organizes them and they work more gradually, right? So yeah, I'm kind of 50-50 on this. All right, so what we will do today, yeah, yep. No, I actually not, because what happens is we usually have the deadline quite late in the semester, and then there is just maybe a week before we have to mark you and submit the grades to the examination office. And almost everybody submits everything in the last minute, and therefore there is a lot of need for getting the peer review happening, right? And everybody is really busy. So instead of having time to do all the peer review, you're forcing everybody to do the peer review in few days, right? And that's a lot of work, because everybody who is doing peer review has to check the code and everything, right? So actually it doesn't work. And what happened last year was people were late with the peer review, and then they get discounted points because they couldn't find people to do the peer review for them, right? Those who submitted the assignments earlier, they could get peer review much easier because the reviewers had much more time, and at the end it is like problematic, right? So that's sort of a small argument for doing the assignments earlier and having deadlines earlier, so there is enough time for doing the peer review. I mean, for us it doesn't matter. Like, we mark you in the last week or so, or last 10 days of the course before we have to submit the grades to the examination office. We always do that this way, right? But for you, you need to collect those peer reviews and do the peer reviews, right? So you grade it on the reviews you're getting and the reviews you're giving, and that is cramping everything in the last minute, right? So that's not too great. Yeah, that's right. So feedback for us is also better if you start doing earlier, because then you ask questions and then we give you hints. And yeah, that's right. Yeah. Yep.
I don't think I quite understood. Do you get punished if no one can do a peer review on your project or assignment?
Yeah.
So if other people don't have time, you get punished for that. That makes sense.
No, that's, you get punished for wrongly organizing your time, right?
So if we deliver by a deadline,
Yeah.
and nobody has time, a deadline set by you, and we deliver it, and people don't have, so other people.
So there are two options, right? So if we have a deadline early, if let's say assignment 1 finishes in 3 weeks, and you submitted it, and then nobody reviewed your assignment, you don't get the discounted points, because it's not your fault. Like, you did it on time, and then nobody, like, for whatever reasons, you didn't have reviews, right? In that case, there is no kind of penalty. We kind of ask people to do their peer reviews, right? Who get punished is the peer reviewers who didn't peer review you, right? So everybody who's supposed to peer review, like three other people, reviewed only one, they get punished because they were slack, right? You don't. But if the deadline is at the end, and you submit it at the end, and you don't get peer reviews, like, there is nothing we can do, right? And there is nothing you can do neither. So that means you should have submitted earlier and tried.
Then the deadline should be earlier.
Yeah, that's right. So that.
Because if you put a deadline and we deliver by the deadline,
Yeah.
and then someone else don't have time, and I get punished for that by doing it in the set time, and then someone else don't have time because there's a lot of projects, then I get punished for that because they haven't managed their time correctly, but I did because I delivered by the deadline set by you. That makes no sense.
Yeah, that's true. So what we normally do, we have the kind of a soft deadline for submissions, but everybody can submit after the deadline. And then we have a hard deadline where you cannot submit afterwards, right? So then if you submitted at the hard deadline, getting peer reviews on you. If you submitted at the soft deadline, the getting peer reviews is not on you. It's like just normal, right? So yeah, I guess that might be a fairer solution, right? If everybody submits at the last hard deadline and nobody has peer reviews, it's like why? Why did everybody waited so long, right? Yeah, but if someone has two friends who will peer review them, they could submit at the very end and have the peer reviews done, right? So then the hard deadline is fine to have quite late.
Say if you from also, for example, I'm in the big set.
Yeah.
So let's say I don't know that many programmers here.
Yeah.
And then I get punished for being in another class because it's a subject I'm able to take.
Yeah.
Or have to. So
No, yeah, that's a very fair point, right? So I think the solution with the soft deadlines where you don't get punished if you don't get the peer reviews afterwards, and hard deadlines where you do, and then if you want to cross the soft deadline, then you have to make sure you will get the peer reviewers sorted, right? That might be the best way to do it. Yeah. Any other questions? Yep. I believe it includes structs as well. Yeah. So you cannot have a constant struct. Yeah, I kind of don't like it, right? I think being able to define something as unchangeable is kind of useful. So there's immutability aspects of some languages are kind of very useful because they help you to manage state. Otherwise, state kind of leaks. State changes can happen in various places. All right, so let's close this. What we will do today, we will talk a little bit about Heroku. So who knows what Heroku is? Yep. What is it? So, okay, let's say I have, so I kind of have a very primitive server here. So I have a server which prints hello, and then the path of where I am, right? So if I modify it to be 8080, it needs to be a string. All right, so let's do this, and I run it. What will happen is Go runtime will compile my code, run it, and then if I go to the browser and say localhost 8080, I will have this hello and the path, right? So if I change the path to be something, then I will have something, right? So now I would like this service to be visible to everybody in the world. What do I need to do? So I have some piece of code. I have some executable. I could have compiled it. I could have compiled it to an executable, right? So I have in my case Mac executable. I could compile it for Linux or whatever. And now I want to deploy it and have it visible for everybody in the world. What will I need to do? Yep. Heroku, yeah. What else? What else could I do? Yep. Yeah, but I have a laptop and I often shut it down and then the service is not visible. So what do I have to do? Huh? Yeah? So deploy somewhere. Where? Yeah, Heroku, but apart from Heroku, what else can we do? Yeah? AWS, right? So what AWS gives me? Yeah? Yep. So I have different options, right? But I need to have a VM which runs my stuff. At the bottom, I have some virtual server. Yeah, at the bottom, I have some hardware which runs my stuff somewhere permanently, right? So I have a computer connected to the internet all the time, and it runs some software stack. So if I get this physical box, I can set up a server at home, buy a PC, plug it into the network, turn it on, and keep it running all the time, right? And put my executable there, and it will work. But then I have to maintain it and so on. So I can use Amazon or Microsoft or some other service provider which does it for me. And I have an option of either hiring a box, physical box, or hiring a virtual box, which is independent of the hardware, right? Or I can go a layer up and use a Docker container or something else, right? But I need to kind of deploy it somewhere in the cloud, which boils down to having a hardware connected to internet all the time, right? So Heroku is one of those services which is quite high detached from the physical hardware, from the operating system, and from the way the containers work, right? So what I do with Heroku is I basically deploy a process which is mapped to a port, and Heroku manages all this stack for me and exposes my code over a particular port to the internet, right? So if I go back to this, so the reason why I cannot say port 8080 here is because once my code is deployed on Heroku, Heroku needs to port map whatever my particular domain is to a virtual process that runs my stuff, and they do this port mapping for me because they don't have gazillions of ports 8080. They have virtual domains which have port 80, and then you access their stuff through that port 80, and they map to whatever you're running behind the scene, right? So you have to do, instead of running your stuff on the port that you want, your stuff will run on port 80 by default on a particular virtual domain that they give you. And then you have to get this environmental variable port, which they give the process when the process starts, right? So your code looks almost exactly the same. The only difference is you have to map, they have to map the port that you will be running on, which you don't know at the compile time because it's a deployment thing, and they have to map it to port 80 of some virtual server, right? So what is this virtual server? Well, you have several options. So one is, so for example, if I go to my dashboard, I created last night a single app, and I got a random name, and this random name has a particular particular IP address, and it will map port 80 from that virtual domain name to my code which runs behind the scene. I don't need to remember it. I just need to say Heroku open to open that yep. So if I say yes, I am in the wrong repo. So Heroku open. So this will kind of look up what exactly my application deployment is, and I have my my virtual server kind of running here. So it basically starts with the same name you have given to your app, .herokuapp.com. So that's how the domain is constructed. And as you see, there is no port attached to it, so it runs on port 80. But inside, my code doesn't run on port 80. It runs on some random port which the deployment service kind of arranged for me, right? And then I have my app running permanently and visible on the online for everybody to see, and I can shut my laptop and it's like deployed in the cloud, right? So how do you do the deployment? Well, you basically do git push Heroku master. Heroku is the Git repository of the Heroku server. So if I do cat git config, you will see that I have a remote, which is basically my app Git repository. And that provides me the link to the repository which is hosted by Heroku. So when I say git push Heroku, which is this remote, it will push to this Git repository and automatically redeploy my app, right? So if I do this, it will kind of push the Git changes, the Git change sets to Heroku. It will trigger the build process. It will build my application and then deploy it and then version it. So I've deployed it for the 9th time, and that's what it says, that okay, they have been 9 deployments so far, and that's the latest one, right? And then if I change my code, I push it to Heroku and then I have it redeployed. You initialize the application by saying Heroku create. So you create a new app when you want to have a new app, and there are some conventions you have to follow. So one convention is that your repo, so if let's see here, so my repo is in a folder, and that folder is the main, like the top level folder for my project, and then all the code is straight in that repo, right? So I don't have folders. I have basically all my code straight in here. So the main module is kind of at the root level of the Git repo, and then you can have submodules here, but they will have subfolders, right? But the main folder is not in the main module is not in the folder, and you have to have Go mod, same as we have with the normal projects. And the difference here is that we have to, they haven't completely moved to Go 1.13 yet, and they misread this line. So then you have to add this comment for the Heroku to recognize that you're working with Go 1.13, right? Without this line, they will misread the version of Go that you're using, and they will use 1.12.9 as a default one, which is not a big deal. If you're not using any of the features from 1.13, you can deploy on Heroku with 1.12, but if you start using some 1.13 features like the error handling, then you need this comment in your Go mod file, right? This, what I'm showing you, is already in the, if you go to, if you go to our wiki, if you go to our project, I have all this code and hello rest. You cannot deploy this on Heroku directly because this is in a folder, right? So I tried it last night, and if you have folders, they will not properly work with the way Heroku default build packs work. So if you try to deploy all this and use this as a binary for running the service, it will not work. You have to isolate this as a single repository and start like from the inside. Like the root level is this, right? So Go mod is that's what I was showing you here, and then you need a proc file, and the proc file is yeah, I show it here. It's bigger font. Yeah. No, so in the top folder you need the proc file, Go mod, those two. Everything else can be in submodules, right? Usually the executable is either in the root or in the command, like that's what we were doing before. That's by convention, but you can do whatever you want. The only two files that have to be in the root folder are the proc file and the Go mod, right? So the proc file defines what sort of instance you want the Heroku to run for you, right? And you have different types, but for the sake of our usage of Heroku, we will use two. We will use the web, which is something that runs on as a web server, maps to a port, and answers HTTP requests, right? So that's the type which I'm specifying here. You may have something which runs on Heroku which doesn't talk to external things. Maybe it's something that triggers some updates of the database or triggers something outside, right? Like a webhook of some sort. In which case, you don't want a web because it's not really mapped to a port and doesn't answer the request. It's something that kind of runs behind the scenes, runs as a background process, right? And this one is called clock. So it's kind of something that is woken up occasionally and make some updates to something, to external service or to internal database. But for now, we're starting just with the web, right? So our proc file is very simple. It specifies what is the default executable that's gonna run, and in our case, because the package, so if you check the package name, the package is called Hello REST, and Heroku will use that name when you build the executable, right? So here you can see that it built and installed an executable called Hello REST by default. So those of you who have the algorithms class, you can go, and the rest will be recorded, but I'm not gonna talk much more beyond the usage of Heroku. And then there are some tutorials and some docs which you can check on the Heroku page. Okay. So here you can see that when I installed it, it used the process type, and the process type was web, and it kind of deployed my executable with this web hooks. I didn't generate it, so if I remove, because then you see that there is no main like executable. I didn't actually build it. You're only submitting the source code, and the Heroku will build it for you, redeploy it for you, and map the ports, right? So you basically don't even need to build it. So you don't even know if it's running on Windows or it's running on Mac or is it running on Linux. It kind of, you don't even care, right? So that's what I was saying, that Heroku is sort of like quite high up in the chain of services, because you don't even know what operating system your stuff is running on, right? What you're submitting is the logic, the source code, and they build it and they deploy it on whatever operating systems or whatever infrastructure they need, right? There are some constraints. So one constraint is with this port mapping, as I told you. The other one is that because they need scalability, they need to be able to answer requests. Like, let's say you deployed this this service, right? So we have this yeah, this app running, right? And now I have one request per minute, okay? So a very small virtualized server can cope with it. What will happen if I have suddenly like 1 million requests per second, right? Yeah? It's gonna crash, exactly. So what can we do to prevent it from crashing? Yeah, we need to add more capacity, right? So how can we do that? How can we add? So let me just, yeah. Anybody? Representational state transfer, right? Yeah, so it's oops, sorry. Well, there is a section of statelessness. Yeah, so that's the, whoops, that's the thing I was getting at, right? So it basically says it is a client-server type of communication, but the constraint is that no client context is stored on the server. So it's basically stateless on the server side, right? All the state is kept on the client side, and you're using this representational state transfer to transfer that state in every request that you need to transfer the state, right? So that's the beauty and the simplicity of the design of the protocol, that it allows this very nice horizontal scaling, because every request can go to somewhere else and it will be handled properly, because you don't need to keep the state on the server side. So that is part of the REST, and that's part of the design of the services that we will be kind of designing in the course. some constraints. So one constraint is we need to remember that we don't have access to the file system. Second, we cannot play with the ports the way we want. We need to follow the rules of the game of Heroku. And third, if we do need to log in the user or have some sort of state, maintaining some statefulness, we need to do that in a stateless fashion on the server and keep the state on the client, right? That's why for database or for some data access, we use external things. So we use Heroku or some cloud functions for the logic, but the data storage and data kind of access, reading and writing, we use some service which gives us the database, right? So we will have a lecture on MongoDB, for example, and we will use Mongo Labs, which is another service provider, which offers this type of storage. And another one which we use in the course is Firebase. It's a Google one, which also uses JSON-like storage for data, and then you can access it via the web APIs, right? So you write your logic as a cloud function or a open cloud or a Heroku service, and then you will talk to your database or to your storage, which sits somewhere else. So we will kind of organize the logic and the storage and access to external resources in a kind of a nicer architecture in such a way as we decouple those components for scalability and for for robustness. So the last thing I will talk today about is the structure of this simple app. So we were discussing it before, but I just want you to get the concept, right? This line runs a web server, right? So we're basically running a built-in internal web server which is defined in Go. So if you think about it, it's like so you have a web server running inside your code. So then, what is a web server? Well, a web server is a process which listens on incoming connections on a port, particular port. Typical port is port 80, or for testing purposes, we often use 8080, right? So you have incoming connections, incoming TCP connections for port 80, which follow the HTTP 1.1 protocol or 2.0, depending how you configure it, right? If I connect to it without the TCP, I cannot connect to it outside of TCP. So if I try to connect it via UDP, it will not work. If I try to connect to it through TCP, but I don't follow the HTTP protocol, it will drop me, right? It will say, you're talking rubbish to me, so I don't want to talk to you, right? But if I follow this protocol and I request some resource, so with HTTP we have kind of let's say get requests and post requests, right? So if I do a get request, then somewhere some logic here needs to handle it, right? So this logic is done through the handlers. So I'm kind of installing a handler which handles particular mapping of the URLs that we have. So I can have installed a particular handler for the root. I can install a particular one for root test or whatever, right? It's up to me. It's up to me to define how is the structure of my web server looks like in code. So then the incoming requests will be handled by a particular handler, right? So that's what we're doing here for the root. We're saying there is a handle function which is called hello handler, and it's gonna handle all requests which start with the slash, right? Because there are no other rules, there is no rule saying /test. /test will also be handled by this handler, right? So effectively, if I did this, every proper request with the starting slash, which means everything, because we always have a starting slash, will be handled by this handler. And the handler has a particular structure. It has a response writer, so it's like a stream to where you send the response, and it has the request of what came from the client to me, right? So the request is what came to me, to the handler, and the response writer is what we will write down. So we usually use the fprint to write to the handler, to the writer, and that's where we usually write the JSON, right? So when we're building some API and we want to respond with the JSON, we usually generate a JSON and write it to W. In this case, I'm just writing a plain string, right? So that's what we were discussing yesterday, that we use those encoders for decoding and encoding JSON back and forth, and using the stream for writing and reading. There was a case yesterday. One student came because he sent a request, he got the response back, he read it using the read all from IO utils, and then he was trying to parse it into a JSON structure, and it was throwing an exception, right? The important thing to understand is that if you have a stream is like a pipe which has a water flowing through it, right? So if I read the bytes, then they are kind of gone, right? So when I have the stream and the starting point is here, and let's say I have something written there and I read it, then I am at the end of the stream and there is nothing else to read. So once you read it once, you cannot pass it somewhere and continue reading it because you've already read it, right? So you can only kind of read it once. You can store it somewhere and reuse it, but reading from the stream you can only do once. You cannot expect that once you read it, it resets itself here and you can read it again. It's like with the file. If you have a file and you start reading a file and you read to the end, you're at the end. You cannot continue reading it. That's it, right? So the problem with his code was that he was reading the data from the request body, printing it, and it was there, it was showing the JSON, and then when he tried to parse it again from the request body, it was throwing an exception saying end of file. And that's because you've already read it. So once you've read it and stored it, then you have to reuse that. You cannot reuse the stream. And you have the stream here for the incoming message, incoming body, and you also have you're generating the body by writing to the response writer, basically here. Does it make sense? Okay. You can have a more advanced handlers by specifying a handle. So you can add a handle to the particular path, but then you need to define exactly how the wiring machinery, how the middleware are kind of handled. So the easiest way to do with the wiring up the logic is to use the handle func. And then the function prototype is basically response writer and the request. So now if you have the assignment and you want to partition your namespace into multiple paths, you basically say, you know, whatever the path 1 is, and then you would do different one for something else, right? So you will kind of define your handlers this way. Those handlers can be in different files. So to organize nicely your code, you can group logically what you're doing. There are some libraries which allow you to do this mapping, this kind of routing, kind of a bit more flexibly. The built-in patterns for Go, yeah, they are not as They are not as powerful as some of the libraries that you might use, but then you're not dependent on the external libraries, right? So the advantage of just doing it like this way is that you're building everything inside Go native, right? You don't need to pull additional library. But there are some libraries. So the one which was really popular last year is called Mux. So that allows you to write those routing rules in more flexible and more powerful way. Those of you who want to use it, fine. Those of you who want to stick to the plain native Go, it's fine as well. Make sure that you organize it logically and make sure that you split the handling in this kind of fashion, because you can always say, okay, I just have one handler which handles everything, and then you have a lot of if statements depending on the path here, right? You could do that, and some of the libraries kind of help you to manage that this way, but that's not, that's not too nice. Nicer way is if you tell the server what are the rules and then have handlers specified for each particular prefix of your path. So that's one thing. The second thing is passing parameters. So I'm not sure if Christopher talked about it, but let's say I want to design an API which allows me to let's say I have a student database, and I have so a student has name and age, okay, and an ID. So now if I have my root and then I say slash, I can say student, and now if I do a get request, right, and I want to say I want to get a student which is of particular ID, right? So let's say I have Joe 24 ID1, and I have Anna 25 ID2, right? And I want to request that I will get Anna, right? How can I design it? Well, one way is you could say ID equals 2, right? So what is it? How we call it? Yeah, it's a parameter. Right? So those are parameters, and then if I have multiple, how do I split them? Say it again. Yes. Right. So I have two delimiters. The first delimiter is the question mark, which says, okay, before the question mark, all of this is the path, right? And these are params, right? Those are parameters. And then I split them using the ampersand. So each parameter is divided by this. Can I use comma? Of course you can. So you can say and 1, right? I could say ID equals 2 or 1, right? So I can kind of combine, I can have a list in my params, and we usually use equals to have a key and value, right? And equality sign dividing them, right? So that's one way. So that's the params way, right? What's the other way to do that? So I could say get blah 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 student, and then I can put ID here, right? I could say 1, or I could say 2, right? And then if I say get student 2, I will get Anna. If I say get student 1, I will get Joe. If I say get student 0, I will say 404, right? So which one is better? Is this better or this better? Exactly, it depends, right? It depends what you want. This one is simpler and it's a little bit nicer sometimes. But for example, I cannot say I want Joe and Anna, right? because I cannot specify two things now. I only can get one at a time, right? Here I could say ID equals 1 and 2, right? So I could say 1, 2, and then I can get both, right? But that means it's much more complicated. What I'm gonna get here as a response? Should I get an array of JSON objects when I'm doing this? Or should I sometimes get an array, sometimes get a single object? Well, it's confusing. You should be always getting the same thing, right? If I have this, I always get one object, right? So if I want Anna and Joe, I will just say get 1, get 2, right? 2 requests, right? And I get 2 things. But then if you want 10 things and you need to do 10 requests, that's starting to become a bit inefficient, right? So it depends. It depends what you need and how the API will be used, right? Yeah?
The first one is not to specify which values you want to get for only the name and the age.
Yeah.
Or the age and the ID.
That's right. That's right. So again, it depends. When you're preparing kind of a more flexible query system, usually we go with the parameters because they allow you to be more flexible. And for query system, you sort of have more options for filtering, for sorting, for paging, and so on, right? So we usually go with this. If you have, if you're following the rest and you have some resources, so a student is a resource, right? And I can access it, and I have the URI, right? So I have kind of a universal resource identifier, right? I want to say I have the identifier which points to Joe, right? Then I will go with this because this one is the URI for Joe, right? And it's always gonna be URI for Joe, given that those are immutable, right? So depending what the design is and depending what you want to achieve, you have to make a choice whether you will go more with this kind of REST-like API, where the parameters of some sort of data is part of the URL, part of the path, or whether you want something more like a query system, where the parameters and some data is part of the params, right? There is no kind of universal answer. Some services tend to go a little bit more towards this REST thing because of this URIs, right? Because then you start having those universal identifiers to reference something. And then if you do that, then you have a kind of a nicer thing for things like get for getting something, post for creating something, update for updating the things, and you can use the HTTP verbs for managing the logic of what should happen on the URI, right? If you do this, it's a little bit ambiguous. What does it mean if I say post, right? With parameters like this. Like, what does it mean? I'm kind of updating the thing. So like with the REST API, like in this fashion, it's a little bit cleaner what is happening with the resource if I'm using the HTTP verbs. And we try to follow the HTTP conventions to use those verbs, like delete, for example, as well, right? So there are some things that you can express using HTTP protocol verbs plus the URIs. Make sense? All right, so I think we'll kind of finish for today. And if you have any questions, let me know. Play with Heroku. Install the command line interface for Heroku, so you can use those Heroku commands like create and open and so on. Play with a dummy app. You can copy this one into your own folder. You don't need to have a GitLab or GitHub or any other repo to start playing with it. So in my case, I have a Git repo. So I basically copied this this folder structure in here, and I said git init. So I have a local Git repository, and then I only added the one remote, which is Heroku, and I don't have any other remote. I don't have GitLab or GitHub or anything. I only have my local copy of the Git repo and the Heroku one, right? Heroku one I cannot pull. I can only push to it. But if you were to copy that to GitHub, you can always add that later, right? So you can create a project, then push it to GitHub or GitLab. But you don't need to have anything remote to just play with Heroku. You can only use Heroku if you want to, and local Git repo. Okay, any questions? Okay, so we will update the assignment specs such that we don't need to use those tokens, and I will let you know. And then next week we will probably talk about the storage, the state, like some sort of a database. So play with Heroku, play with the structure of the web server. Yep. Yeah. So wait with the assignment because we will redefine what you need to do, such that we don't need to rely on the tokens. Yeah. Right. I love it.